What is a circle, beta?
It's a closed figure.
Yes, it is a closed figure. Does it has any edges, any vertices and more?
No.
No, it does not have any edges. Edges are in a figure that has the lines, right? And this way, these are the
Yes.
edges. Do we have vertices in a circle? No. So a
No.
circle has no edges, no vertices, and what more, beta? And there is one unique property in a circle. What is that unique property called? From the center of the circle, if you measure all of the points on the closed,
Quarter.
then what are they, beta? They are always equal from the center, right, Laiba?
Yes.
Equidistant. What do we say? A circle.
Equals.
Okay, circle is a two-dimensional shape in which all the set of the points from the center of the circle to the curved surface are equal in length or equidistant from the center point. Okay, and circle has no edges as well as no vertices. So this is about circle. Okay, so in the 9th grade curriculum, in the CBSE curriculum, you're going to study chord as a major concept. Okay, what is a chord in a circle, beta? A chord is nothing but it touches the a straight line that touches the 2 points, right? 2 points on the circle, right?
Yes.
Both of these points lie on the surface of the circle, correct? So a chord of a circle is a straight line segment whose endpoints both lie on the circle, correct? Both lie on the circle. You know, this region is called as arc. This is a minor arc and this is a major arc. You just have to remember this concept, okay? The region covered by this chord, this is a minor arc and this is a major arc. Fine? Fine?
Yes.
Okay. A chord that passes through the center of the circle, what do we call that chord as?
And
What do we
diameter.
call it? Yes. Which is the largest chord in a circle? Which is the largest chord in a circle, beta?
Diameter.
Diameter. Yes, diameter is the largest chord because it touches the center of the circle and it is the most widest portion of the circle. Okay. It covers the widest part, correct? Which the line that passes through the center of the circle covers the widest part. So these diameters that passes through the centers of the circles are all the largest chords, correct? Okay, so this was about the chord. Then what did we discuss? We discussed about the angle subtended by a chord at a point. What is an angle subtended by a chord at a point called? For example, if you have this circle and if you have a point O, okay, and if you have a chord here, okay, it is named as AB. Okay, if you have an angle AOB, then what is an angle subtended by chord AB at O? Can you tell me which is an angle that is subtended by chord AB at O? Tell me the name of the angle, Laiba.
Um,
What is the line? What is the angle subtended by chord AB at O?
Angle AOB.
Excellent. This is an angle. Okay, that's all we are going to study today. So, what is the angle subtended by this chord at O is angle AOB. Now, if I'll have AC, a C is an angle. Now, just tell me, what is the angle subtended by chord AB at C?
ACB.
Yes, ACB. Angle ACB is an angle. So, about these angles, we are going to study in the 9.1 topics. Okay, angle subtended by the chord at a point. Okay, there we are going to study theorems, two major theorems. In that, okay, this is just the same thing that I've taught you. Okay, okay, in two major theorems, the theorem number 1 states. What does the theorem number 1 states, beta? Just state it. It is nothing but equal
Equal
chords of a
parts of the
circle
circle subtend equal
produce,
angle at the
yes,
center.
they subtend equal angles at the center. So equal chord, for example, AB and BC, AB and CD are equal chords. What does equal chord mean, beta? They have same length. Like if this CD is 5 centimeter in length and if AB is 5 centimeter in length, then if two chords are equal length, then if you subtend an angle at the center of the circle, then which and which angle are equal? Please tell me. Like which angle is equal to which, beta? Yes.
COD is equals to angle AOB.
Excellent. So what is the statement is nothing but if CD is equal to AB, then angle COD is equal to angle AOB. How did we prove this bit? Wasn't it easy? Very easy. It was very easy, right? How did we prove? We just made this construction of two triangles. And then what did we discuss here, beta? Two congruency, right? Congruency in two triangles you had to prove. That's all, correct?
Yes.
How did you prove the congruence in these two triangles, beta? Do you remember? How did you prove congruence in two triangles? We have two radii here, COD. These two are equal. These two are equal. Fine. And then what more, beta? What more was equal? What more was equal? Do you remember something that is given? That chords are equal, right? AB and CD are equal. This is given.
Yes.
Equal chords of a circle. This much is given. This obtain equal angle at the center is to be proved. So, which postulate do you apply here, beta? Yes rule, right? After applying yes, this is postulate. What did we prove here, Liva? Is it not COD is equal to CP?
Yes.
Yes. CPCT. What is the rule called? CPCT. Done. Understood or not? This is the first theorem, which is what does the first theorem state again? Please tell me. It is nothing but equal chords of a circle subtend equal angle at the center. What is the vice versa of this theorem? Can you please tell? Just the opposite of this theorem. Can you please tell what is the vice versa of this theorem? Converse of this theorem? It is nothing but if angles subtended at the center of the circle are equal, then Aliba, come on, beta. Give it a try. What is it? Actually, the first theorem states that if equal chords are there, then the angles will be equal. Now, vice versa of it is nothing but first you have to start with angles, right? If the angles obtained at the center of the circle are equal, then the chords are equal, right? Yes, understood. The same as the theorem too. If angles obtained by the chords at the center of the circle are equal, then the chords are equal. Wasn't it easy?
Yes.
Yes. How did we prove? Again, it was the same concept. How did we prove? It is nothing but by the postulates. The same postulates. But instead of yes, this is postulate, we have to apply yes, as because an angle is given, right? Instead of sides. That's what. Done? Was it easy? Going
Yes.
easy till here? Any doubts still here?
No.
No, mashallah. So there was one problem that we discussed. The same problem, this problem had two congruent instead of single congruency. Okay, they said two. This one, right? Two chords in two different congruent circles. So it was the same proving the congruency in two. Instead of one, you're proving it's the same as theorem one. Just two different circles you have to form. That's all. Okay. Done. Was it easy? We had discussed this again in the last class. Twice. These problems were discussed twice. Okay. This is same as theorem 2. Fine, beta?
Yes.
Theorem 2. So, we have discussed two theorem till now and two problems. We last time we discussed more of the theorems, right? Perpendicular from the center to a chord. And the next to this one is based on the perpendicular of the center of the circle to a chord. Okay. If you have a chord here, beta, if it is called as AB Liba, okay?
Yes.
If this is a chord and there is a point O, and if you draw a perpendicular from this to this, okay? Okay, Liba, if you're going to draw a perpendicular का मतलब क्या होता है बेटा? Is it not 90 degree? Yes, correct?
Yes.
अगर हम perpendicular draw करेंगे, तो it will bisect it. Okay, what did we discuss? Theorem number 1 में हमने क्या पढ़ा था? What was theorem number 3 in this? Perpendicular from the center of the circle will bisect the chord, correct? Bisect का मतलब क्या होता है बेटा? Perpendicular from the center of the circle will bisect the chord. Where is the chord here?
Divided into two equal
Yes,
parts.
it divides into two equal parts. So where is the chord in the circle, beta? Is it not AB? Here? Can you see? Yes, AB is the chord. Okay, which is a perpendicular here? OM is a perpendicular, right? OM, if we'll produce OM till AB, then what does it do to AB? Doesn't it divide into two equal parts? What are the two equal parts that is made? Is it not AM is equal to MB?
Yes.
Yes, we are going to prove this, right? We should prove this. How will you prove this? Again, what are we going to do? Again, can we not construct the triangles? Yes, we're going to construct the triangles. We are going to prove it. We are going to prove through the which postulate. Do you remember which postulate did we apply? It was quite easy, very, very easy. This and this are 90-degree, fine. This and this are two sides. Two angles, two sides equal. Correct? And one is a common side. Three are done. So which postulate? Yes. A. Yes. Through SA's postulate, these two triangles are congruent. Hence, AM is equal to MB. Are we done? Any doubts? Any doubts in theorem number 3?
No.
No doubts, right? What did we do? We just made a construction here. We did a construction here. And what we do? We proved this is equal to this. This and this are common sides. And what more? This and this are 90-degree, right? Why are this 90-degree? Because this is a perpendicular. So yes, yes, two sides and one angle are equal. Hence, two triangles are congruent. If two triangles are congruent, AM is equal to MB is fine. So the theorem 3 statement is done. It is nothing but if a perpendicular is drawn from the center of the circle to the chord, then it bisects the chord. That's all. Correct? Yes. So this one theorem number 4 is nothing but converse of theorem number 3. Can you please tell me how will it be? If you draw a circle, beta, if you have a center point, if you have a chord, it should be converse. उल्टा उल्टा बताना है तुम्हें. हमने first prove किया था AM is equal to MB. But what you have to prove is the line is perpendicular. You have to prove that this is 90-degree and this is 90-degree. These two are equal. You have to prove that this and this side are equal. How will you prove this? How will you prove it, Laiba? Can you please tell me how did you prove it? What are we going to prove? Angle AMB, angle AMO is equal to angle OMB. Okay? Is equal to 90-degree. This is what we are going to prove. What is given? The line drawn through the center of the circle which to bisect the chord, which bisects the chord. So given is AM is equal to MB. We are going to prove is angle AMD is equal to angle AMO is equal to angle OMB. Okay, that's all. So we'll see. How did you prove this? It was quite easy. Just see this, beta. What we have to prove that this and this are equal. If this and this are equal, they must be 90-degree, okay? Because if two angles are equal, they must be 90-degree. Because half of it, right? They are standing on the straight line and they must be 90-degree. You know this rule, right? So we know this is equal to this, correct? And this is equal to this is given already. OM is equal to OM. Which postulate do we apply? Is it not SSS postulate?
Yes.
Yes, three sides are given. If SSS postulate is applied, this angle is equal to this angle by the CPCT. So understood all the 4 theorems. Can you please state all the 4 theorems here, beta, please? I want you to state all of the 4 theorems now. I'll draw a circle for you. Tell me what and all did we discuss till now. Okay, if you have this as a circle, Laiba, what did we discuss in the circle, beta? Let's draw a midpoint. Laiba, theorem number 1. Please state the theorem number 1, beta.
Equal chords of the circle, subtend equal angles at the circle.
Excellent. If you draw two equal angles in the circle, then they subtend equal angles at the center of the circle, right? Okay, what is the converse of theorem 1, beta? Laiba, what is the converse of theorem 1, beta? Theorem number 2 states that if angles are equal, then the chords are equal. The opposite of it, just you have to tell. If the angles subtend at the center of the circle are equal, then the chords are also equal. That's all, right? So this was the diagram for the first. Now tell me the theorem number 3 and 4. What did we discuss in 3 and 4? It is nothing but the perpendicular drawn from the center of the circle to the chord bisects the chord, right? Right, Laiba?
Yes.
Any doubts in that? No. What is theorem number 4? It is nothing but the converse of theorem number 3. It is nothing but, what is that? If a line bisects the chord into two, then the angle produced from the center of the circle will be equal to 90 degree, right? Will be perpendicular to the chord. Correct? That was the theorem number 4. So all the 4 theorems are clear?
Yes.
Yes. So we have 2 more theorems that we discussed in last class. It is nothing but how to calculate the actual distance from the center of the circle to the chord is nothing but the perpendicular from the center of the circle to the chord is actually the chord length, right? Distance of a chord from the center. How to calculate distance of the chord from the center is nothing but from the center, what you have to take is a line, right? Well, how will you calculate the distance of chord AB from center, beta? I just told you how will you calculate from the actual length. I told you in the previous slides, it was shown that how to calculate the length of AB. Laiba, how to calculate the length of the AB from the center of the circle, beta? Did not tell you that if you draw a perpendicular, then this is called as the length, right?
Yes.
Distance, correct? I showed you with an example each, right? And this, which is used to in this figure, which is used to calculate the length of this point from this length of AB from the point P. AB का डिस्टेंस कितना है पॉइंट P से दिखाने के लिए आप कौन सी लाइन को चूज करोगे? We had already discussed. It's very important. Which line will you choose to calculate the distance of AB from P? Is it not PM? Laiba, I cannot hear you. Laiba, I cannot hear you. Yes.
Hello. Hello.
Yes, are you back?
Yes. Can you hear
I
me?
am I audible?
Yes.
Okay, mashallah. So what were we discussing, beta? It is nothing but actual distance, right? What is an actual distance from a point to the chord? How will you calculate it? Laiba, how do you calculate? How do you calculate the actual distance from a point to the chord? Is it not by the perpendicular drawing?
Yes.
Yes. So the statement is the length of the perpendicular from a point to a line is actually the distance of a line, right? So if you are having this point and a line here, is called AB, then to calculate the distance from this point O to AB, what you have to do is you have to construct a perpendicular, right? You cannot calculate it by drawing a line to OA. This is not the actual length, okay? OA is not the actual length of a point O from AB, okay? So OM, this is actual length, okay? This is just to define this that the OM, the perpendicular drawn from the center of the circle to the chord, gives you the actual length, okay? This is very important for you, Laiba, in the next theorems, okay? Next theorem, let's see what is the statement of the next theorem, Laiba. Chalo, come on, let's quickly see what is the statement. Okay, we have discussed just the 4 theorems, right? Can you please recap what are the 4 theorems are? First theorem states about the equal chords have equal angles, correct? Second theorem, equal angles have equal chords. Third theorem states that perpendicular bisects the chords, right? Yes. Now, what is the theorem number 5, Laiba? Equal chords of a circle are equidistant from the center. Is it not similar to the previous ones?
Yes.
Yes. In this, the statement is AB and CD, if they are equal, then this length, this perpendicular, okay, this is the combination of theorem number 1 and theorem number 3. Okay, the perpendicular drawn is actually equal. Okay, equal chords are subtending the equal distance at the center of the circle. Fine, Vita? Any doubts in this? If you draw two equal chords AB and if you have OM and ON, then OM is equal to ON. Is it not? Yes, correct. AB equals to, if AB is equal to CD, then OM is equal to ON. Understood? This is theorem number 5. You do not have to prove this, okay? What is theorem number 5 states? It is nothing but equal chords of a circle are equal distant from the center of the circle. Okay? I cannot hear you. Are you muted?
Yes.
Okay. Alhamdulillah. Understood everything? Okay, what
Yes.
about theorem number 6? It is just the vice versa of the theorem number 5. It states that the chords equidistant from the center of the circle are equal in length. The chord that are equidistant, OM and ON are, if they are equidistant from the center of the circle, if OM is equal to 2 and ON is equal to 2, then AB is equal to CD. Then chords are equal. Now, can you please state theorem 1 to 6 without seeing your textbook, please? You have the circles, please draw it and send and share what word we studied from theorem 1 to theorem number 6, Peter. Can you please recap? Laiba? Let's start with the theorem number 1, please.
Equal chords of circle have equal angles.
Equal, subtend equal angle at the center. This is the theorem number 1. Very good, excellent. Now tell me, what does the theorem number 3 and 4 state?
Equal angles.
Theorem number 2 states that if equal angles are subtended at the center of the circle, then chords are equal. That is vice versa of theorem number 1, right?
Yes.
So theorem 1 and 2 are clear. So now tell me, what does theorem 3 and 4 states?
The perpendicular
Yes, very good. A perpendicular drawn from the center of the circle to a chord. What does it give you, beta? What does it do? A perpendicular drawn from the center of the circle to the chord. Please state, what does it do? Does it not bisect the chord?
Yes.
Yes, this is the theorem number 3. What is the theorem number 4? If there are two, if a perpendicular, if something bisects the chord into equal to, then that is nothing but perpendicular to the chord. That's all. Okay. It is thus the vice versa, that the converse of theorem number 3. So what is theorem number 5 and 6, beta? It is same as theorem 1 and 2. What do we do? Two equal chords if we produce, then they're actually equidistant from the center of the circle. In theorem 1 and 2, you had equal angles. In theorem 5 and 6, you will have equal length from the center of the circle. Understood? Any doubts till now, whatever you have studied?
No.
Laiba, how many theorems did we study?
6.
How many theorems did we study, beta?
6.
These are the 6 theorems that are very important in this classes. You do not have more theorem, just 1 or 2 you might be having after this. Okay, 1 or 2, just the 2 theorems you might have, and few are not for the proof, just for the statements. Okay, inshallah. So these are the 6 important theorems that you'll be learning, and inshallah you'll have an exercise problems now for that, inshallah. So we'll be studying one example problem now, and we'll see if we can cover the exercise problems in today's class or not, inshallah. So the first example problem, the question they have asked is, if two intersecting chords, okay, if two intersecting, Laiba, please tell me, what does intersection mean? Can you please tell me what does intersection mean? If this is a line, and if there is another line from here, if there is one road A and if another road is passing through this, then we call as two roads A and B are intersecting each other, correct?
Yes.
Intersection and point we also call it, right? They are intersect at a point or at the junction or a circle. In this way we call, right? For example, if we take a road as an example, then they tell that two intersection point is called as a circle or a junction or something like that, correct? They make a circle there and the traffic signals are being opted there. So this intersecting chords ka matlab hota hai two lines that are intersecting at a point and make a point that is common for the both of the lines, correct?
Yes.
So the question states that if two intersecting chords of a circle make equal angles with the diameter passing. So for example, here they have taken two intersecting chords AB and CD, okay? Let these two chords be there, AB and CD. The next thing that they told is make equal angle with the diameter passing through their point of intersection. What they have told is from the point of intersection, if we pass a diameter, do you know diameter passes through the center of the circle? Yes, correct. They pass to the center of the circle. We also mark a point O. Okay. So these two are the chords. Laiba, please concentrate. AB and CD are the chords, and PQ is the diameter. You know, diameter passes through the center of the circle, so we mark O point on it. So how are you going to construct a figure? If you have the circle, then write two intersecting chords, AB and CD, right? These two intersecting chords are there. Where are they intersecting at? Let's name this point as A. Okay. Then they have told you, if you draw a diameter passing through the center of the circle, for example, this center of the circle is, here is the center of the circle and it is O. Okay. This is the center of the circle. Okay, this is done. Till here they have told you. Then they have told you that equal angles with the diameters. So diameters से अगर आप इसको angles measure करोगे, तो this angle and this angle are equal. It seems this angle and this angle are equal. Okay. Point of intersection. Now what are you going to prove is prove that the chords are equal. You are going to prove that AB is equal to CD. How will you prove this, beta? Do you have any idea how we can prove this? Any idea? It's actually quite easy. You can do it in two ways. I'll just tell you how to do this. I'll just maximize this figure for you. Okay. You have the circle, beta. Okay. Clear everything. Okay. You have the circle, Laiba, and you're having the two chords. Now, please tell me what are the chords mentioned here, beta? Please tell me chord names. Laiba, what are the chords? Please. AB and CD, right? CD are the two chords. And what is the diameter, beta? What is the diameter constructed here?
PQ.
PQ is the diameter. Where does it pass through? Where does always the diameter passes through? Diameter always passes through Center, right? Center of the circle. Center of the circle is named as O. So this diameter PQ is passing through the center O, and also they are told that they are passing through the intersection point. So both of it is done. And what is given, beta? What is given? That angle formed by the diameter to this chord is equal. So angle LEO or angle AEQ. What is given? AEQ or angle LEO also you can write, right? LEO is equal to angle EQ is equal to angle, LEO is equal to angle, what beta? QEM, QED or OED. This is given, okay? This much is given. Have I understood? Any doubts still here? This much is fine. Now let's construct something. Let's construct two triangles. Why are we constructing this? Just to prove that AB is equal to CD. How can we prove this? Just construct two triangles. So what are we going to prove here? AB is equal to CD. Do you have any idea how we can prove this? Just using the triangles. Can we not prove the congruency and then prove that these sides are equal?
Yes.
Which sides can we prove equal, beta? Just tell me which sides can we prove as equal? Do you remember? Do you remember a theorem? A theorem that states that if OL is equal to OM, then the chords are equal. Which is the theorem? Please tell me. If OL is equal to OM, what are OL and OM, beta? The distance, right? It is theorem number 5. What is theorem number 5 states? If the distance of a chord from the center of the circle are equal, then chords are equal. Yes, that's theorem number 6, right? Theorem number 5 states in different way. Theorem number 5 states that equal chords subtend equal chords have equal distance from the center, right?
Yes.
Equal chords have equal distance from the center, or if in the theorem number 6, equal distance from the circle gives you equal chords. Okay? So to apply theorem number 6, what you have to prove is OL is equal to OM. How will you prove OL is equal to OM? It is just by congruency. Simple rule of congruency. What will you consider now, beta? Can you not consider two triangles? Which two triangles will you consider? Triangle LEO and triangle OEM. Now, please tell me which are the points of congruence here. Tell me the sides, tell me the angles to prove congruency. Very easy. It's quite and very easy. Aliba, these two triangles, beta, please tell me how will you prove congruence in these two triangles? It's very easy. Which is common? Please tell me which is the common side here. Is it not OE is equal to OE? Because they are common in both the triangles. एक तो मिल गया हमारे पास. एक something is given. What is given? LEO is equal to OED. Is it not? Angle LEO is equal to OEM. Okay, it's given. Why is it given? Do you remember it's given in the question that the diameter subtends the equal angle at the center of the chords. Okay? So this is given. We need one more thing. We have one side, one angle. We need one more angle or something. Do we have one more angle that this angle is perpendicular drawn? Yes, right? LO is perpendicular drawn, correct? To the angle, to the AB. So if this is 90 degree, is it not OLE is equal to OME is equal to 90 degree? Is equal to 90 degree. Fine. So which are the three things that we proved? Is it not side, angle, angle? So which postulate will you apply? ASA? ASA is fine?
Yes.
So we apply ASA postulate and say that OL is equal to OM. If OL is equal to OM by theorem 6, what does this theorem state, beta? If the distance from the center of the circle to the chord is equal, then the chords are equal. Do you want me to turn the slides back. Let's just see what is in the previous theorem number 6. Theorem number 6 states that if chords are equidistant from the center of the circle, if they are equal in it, sorry, the chords equidistant from the center of the circle are equal in length, right? If the chords are equidistant, the distance is equal, then the chords are equal in length. So the theorem number 6 is the proof for this. Fine. Any doubts till now, whatever you are studying? Any doubts here, beta?
No.
So should I prove it again?
No.
Okay, mashallah. So alhamdulillah, this is done. You can prove it in another way as well. Do you want me to prove it in another way? It's actually a difficult way. I think it's given in the textbook. They have actually framed L angle. They have proved first the angle LOE and EOM. They have proved these are equal, and then they have gone for the next part, next congruency. Okay. Now what I have proved is direct the congruency and proof. Okay. Direct proof of the congruency in this question, and it will be easy for you. Okay. We'll just see one exercise problem. Example problem number 1 is done. We'll just see one exercise problem. Okay, beta?
Yes.
Are you ready? So we have, okay, the question is construct two circles of radii 5 centimeter and 3 centimeter bisected 2 points. And the distance between the center is 4 centimeter. Find the length of the common chord. Let's just do a simple construction. How do you construct actually in a book? Is you just draw through the compass, you draw a 5 centimeter, right? 5 centimeter circle, right? You mark a center point to that. And then the question asked here is, Vinam, if you have a 5 centimeter circle and if you have a 3 centimeter circle, okay? You are having two circles of 5 centimeter and 3 centimeter. Come on, tell me, what is the radius to the circle now? How will you draw the circle actually? You're going to draw it through the radii, right? You're going to take a compass, put on this point O, and then measure 5 centimeter and draw a circle, right, beta?
Yes.
Yes. Now, then they have told you is after there is a 3 centimeter intersect at 2 points, okay? And the distance between their centers is 4. So, this is a center circle at 5. Between the centers, they have distance 4 centimeter distance. So, ये और this point O और M एक और circle के बीच में आपको 4 centimeter gap होना चाहिए, ठीक है? You will draw a 4 centimeter gap, 4 centimeter gap, and draw a circle here, okay? Draw a circle from this point M. You put a compass here on M point and draw a circle now. After giving a 4 centimeter gap, and that circle should have 3 centimeter in length. Okay, beta? Are you understanding? Okay. Circle should have 3 centimeters. So let's just frame a circle here and just put it here. Yes, this would be fine. Okay?
Yes.
Okay. This is another circle. If this is a circle, the question they have told you here, please read it out, beta. Two circles, they intersect at 2 points. This is fine. The distance between the center of the circle is 4. Find the length of the common chord. Can you please draw the common chord between two of this circle? How will you draw it, beta? Okay, let's just think. Common chord किस तरह draw करोगे आप? Common chord का मतलब क्या होता है, Eliba? That should be in between two of the circles, correct? It should touch two of the circles as well. If you're going to draw this line, it should touch both of the circles. So which point does in this entire circle touch two of the circles is this point, okay? Is it fine? समझ में आ रहा है? Okay. This line, ये जो line मैंने अभी draw किया है, this will touch both of the circle at this point and this point. Fine. So let's name it as AB. Let's let this be 5 centimeter. This is 4 centimeter. This circle यहाँ से अगर आप लोगे तो this circle has 3 centimeter in length. Now, what is the length of the common chord? Can you please tell me what is the length of the common chord? What is the length of the common chord? How will you measure it, Peter? It's quite easy. Can you give it a try, Laiba? Okay, I'll just change this figure to this. Okay, just how will you measure? Please tell me, how will you measure the common chord length? Where is the common chord? What is the length of AB? Please tell me. Laiba, what is the length of AB? It's given in the figure. Okay, let's prove this if you want. Okay, we have OA is equal to 5 centimeter, correct? OA का मतलब क्या होता है? We are going to draw this line to this point and this line to this point. Why are we drawing this? Just to make a construction and to prove that this is equal to this perpendicular to the common chord is bisecting it. Okay, if this bisects it, then it divides this whole line into two equal parts. So if this line is 6 centimeter, then this perpendicular drawn to the chord actually divides it into two equal parts, that is nothing but 3 centimeter and 3 centimeter. So it is actually, if the diameter, they have already told that it is a diameter of the circle, right? If it is a diameter that is going through the circle, then it is nothing but 3 centimeter and 3 centimeter as a whole. If you want us to prove it is nothing but OA is equal to 5 centimeter, if O is equal to 5 centimeter, we also know that O, if this is O dash A, okay, O dash is equal to 5 centimeter and OA is equal to how many centimeters? It is 3 centimeters, right? Here to here is 3 centimeter. We already know this. If this is equal to this, and we also know that the center and this circle O dash and O, the distance between O dash and O is equal to 4 centimeter. It is already given, it is 4 centimeter. So as the radius of the circle, bigger circle is more, and the distance between the two centers, so the center of the small circle is actually inside the bigger circle, correct? So if we draw a perpendicular bisector from OA, then this is a perpendicular bisector actually. Then what happens is OA is equal to OB. If OA is equal to OB, then they both are equal, right? If this is 6 centimeter in length, it actually bisects it, so it is 3 centimeter and 3 centimeter. It's quite easy. Do not have to prove all of this. It's actually very easy. What it is nothing but if it is 5, this is 4, and this is this, and actually it stands inside the circle. We know that OB is equal to 3 centimeter and this is equal to 3 centimeter. That's all. 3 plus 6 is the actual answer. Okay, length of the common chord is 6 centimeter. Done? Understood? Laiba, is there any doubt in this? It's actually quite easy. You know how to do this? Will you explain how to do this? I just explain to you in my way. You just draw a circle here, okay? You draw another circle here. Okay?
Yes.
Then what do? You measure the angles. You measure the sides. It will actually be, this one is a diameter, this one is a radius, this one is a radius. This one is a 3 plus 1 because there is a distance between this and this. 3 plus 1. This is 3. If this is 3, if this is 3, what is this chord totally? It's nothing but 6 centimeter. That's all. Okay? Quite easy. If you want, you can prove it as well. Okay, chalo. I think we have time for the class. I will see this one problem, inshallah, and then we'll just end of this session, okay? But there is a question here, okay? What the question states is if two equal chords of the circle intersect within the circle, prove that the segments of one chord are equal to the corresponding segments of the other chord, okay? What does this mean, beta? Can you please tell me what does this mean? Segment का मतलब क्या होता है? Segments का मतलब क्या होता है बेटा? If this is a full line, okay? If you have AB, and if you have mark A, now please tell me what are the segments here? Laibu, what are the segments here, beta? A is a segment, right? Segment AE and EB are two segments, correct?
Yes.
इसको segments बोलते हैं, ठीक है? If you have a circle and if this is drawn in this way, then this is a segment. This is a segment, ठीक है? Segments का मतलब होता है part of a whole, correct? If this is AB, AE is a segment. Now in the question they have asked, prove that segments are equal. Not to prove AB is equal to CD, they are asking you to prove that AE is equal to DE and CE is equal to EB. Okay? Read the question again. if you're drawing two chords, okay, two chords of equal length, the question is, if you're drawing two chords of equal length and then prove that, then what are you going to prove that if there is intersecting point E, then prove that AE is equal to EC and DE is equal to EB. This is what you're going to prove. How will you prove this? It is very easy. It's just by the theorem number 5 and 6. How will you prove this? We'll see now, or inshallah, if time permits, we can see now or in the next class. Okay, just we'll try out this question, inshallah. So first, what are we doing here, beta? First, you're going to construct a circle. Yes.
Yes.
Then you're going to draw two chords. What is given? AB and CD. Two chords are drawn, right? Then what they told is two chords are equal. This is given. What is given, Laiba? Chords are equal. Matlab AB is equal to CD. Correct, beta?
Yes.
This is given. Next, circle intersect within the circle. Fine. Prove that the segments of one chord are equal to the corresponding segments of other chord. What to prove? Please tell me what to prove, beta. I just told you what to prove. How? What to prove? Segment का मतलब क्या होता है? इसमें जब intersect करता है इसको, जब it divides, then what are we going to do? We are getting two segments here. AB. What are the two parts of AB? A, M, E, B are two parts, right? Three parts. CD का three parts होंगे यहाँ पे. CE, CM, CN, D. All of these are segments. What are we going to prove is AE is equal to ED and CE is equal to EB. Okay, this is what we are going to prove. How will we prove AE is equal to ED and EC is equal to EB? Let's start. Can we begin? Or should we just dismiss this class? We just have a little time left. Can we not start in the next class?
Yes.
Okay, inshallah. So we'll see all of this in the next class. And just remember how to do the constructions. Okay, they won't give you the constructions, but they'll just give you this question. You have to construct these circles. Okay.
Yes.
So please read out the questions and try to figure out how to construct each of the figures. Okay. These are very easy, quite easy. These rough diagrams, you don't have to make a very perfect diagram, but it should be actually a rough diagram, but it should be helpful for you to prove all of the points in the answers. Okay. Inshallah. So this was the class for today. The next topics will be discussed in the next class, and you are going to send me the homework by writing all of the theorem number 1 to 6 in a separate book, and send me the statements as well as the proof of theorem 1 and theorem 3. Okay, can you do this homework today?
Okay.
Okay, inshallah. Please write down all of the theorem 1 to 6 without seeing.